So we are looking into the tutorial 5 question 3 about the n eggs dropping from n stories. Before we go into the solution for that, maybe let's take a step back and look at a simple version of it. Suppose we have 10 stories and 1 egg. What's the minimum number of times that it will take for me to find out what is the level whereby the egg drops? Well, it will then be equals to 10, because I have to drop my egg at level 1, level 2, 3, 4, 5, 6, and possibly up to all the way to level 10 in order to find out the solution. So let's look at the next scenario. Let's look at if I have 100 stories and I have 2 eggs. One of the way I can do it is that I can first drop at the so-called the divide and conquer. I can drop at 50. If it doesn't break, then I'll drop at 75. If it doesn't break, I'll then continue up again, and then I'll just continue on to try to find the location where it breaks ultimately. The downside of this is that if it breaks at the first drop at level 50, I will have 1 egg remaining, and I have to drop at one time from level 1 all the way to 49. So this is going to cost me 50 times. So potentially this will incur a cost of 50. So obviously this way is not optimal. Well, there can be a better way of doing it, which is I drop at level 10, 20, 30, 40, 50, and if it breaks, then I start from the last level and then I go up. So when this occurs, the worst case scenario will be when the egg will break at level 99. So I will have utilized 10 tries and then 9 more tries from 11 all the way to 99. So in this case, my minimum will be 19. Well, is there a better way? And there is a better way for the 2 eggs and 100 level solution, which is I drop first at level 14, and then level 27, level 39, 50. So the difference between the two levels is 14 first, then 13, 12, 11, 10, and all the way. And this guarantees us a minimum number of 14 tries. Okay, so this is how we solve the 100 levels and 2 eggs problem. So let's try to generalize this and come up with the algorithm for the n eggs and the m levels problem. So once again, we'll start with the simple scenario whereby I only have 1 egg and I will have m levels in the building. So evidently we know that for n levels, it will take minimum number of m tries. So if I have 1 level, it takes me 1 try, 2 levels, 2 tries, 3 will take 3, 4 and 4, and so on. So this is the trivial example. Let us now look at the scenario with 2 eggs. So right now we're going to be considering the option when we have 2 eggs. Notice that we are going in this down direction and iterating through the levels. When we have 2 eggs and at level 1, it is trivial and we know that the answer will be 1. So this is the iteration when I have 2 levels. I have to consider when I have 2 eggs and I'm at level 1, and 2 eggs when I'm at level 2. So I'm going through the iteration in this manner. So in this line, I have 2 eggs. I'm going to drop an egg at level 1. So if I have 2 eggs, I'm going to drop my egg at level 1. If it breaks, then I have my solution. So I'm done. If it doesn't break, then because I'm at level 1, I'm left with 1 level and 2x. 1 level and 2x. The optimal solution is over here, which is equals to 1. And so I put the 1 over here. Okay? So once again, I'm going to say this. So I now have 2x. This is for 2x. I'm now iterating through level 1 and level 2. I have 2x. When I iterate through level 1, and let's say if my egg breaks. If my egg breaks, I have my solution, and so I don't need to do anymore. But if my egg does not break, then I have 1 level remaining, because my building has now 2 levels. So I need to find the solution when I have 1 level remaining with 2 eggs, and that's how I get the number of 1 over here. Okay, let's iterate through this right now when I have 2x at level 2. When I'm dropping from 2x to level 2, there's again 2 options. If it breaks, or rather the simple case is if it doesn't break. If it doesn't break, then we have the solution, and we need not do anything anymore. What happens is that if it breaks, then we have 1 egg remaining and 1 level, and that's how we get the number 1 over here. So we have 1 egg remaining and 1 level. Okay, the next thing we do is the following. This current drop, it means the current drop that the current try that you're dropping your egg in. So it will always be 1. This 1 is this 1 over here. We are going to take the maximum between the break and the don't break. This is somewhat like the worst case scenario that will happen at level 1 for 2x and level 2 for 2x. So the maximum of this together with the current try will be 2. The maximum of this 2 plus the current try will be equals to 2. And then from this 2, we are going to take the minimum from here, because we want the minimal number of tries that you need to find out the number of tries you need to find out which level the egg will break at. So I'm going to say again. First, you take the maximum of this 2, which is 1. You add it to the current try that you are dropping the egg at, which is 2. And you do it for the next level as well. So the maximum will be 1. The current try is 2. We have 2. And then you take the minimum of this, because you want the minimum number of tries it takes to find out which level the egg breaks at. This is the optimal solution for a building of 2 levels and of 2 eggs. Okay, so now let's increase the number of levels to 3, and we need to iterate through the 3 levels again. So right now I have 2 eggs and 3 levels. So let's say I drop at level 1. This is my current drop. I have 2 options: if it breaks or if it doesn't break. If it breaks, then I have found my solution, and so it will be 0. If it doesn't break, I will have 2 eggs and 2 levels remaining. This gives me this number over here, 2x and 2 levels remaining, 2, which I'm going to put over here. Next thing is level 2 with 2x. Again, 2 scenarios, either it breaks or it doesn't break. If it breaks, then I only have 1 egg remaining and 1 level. So if it breaks, I have 1 egg remaining and 1 level to find my solution. And if it doesn't break, I have 1 level remaining, but I now have 2 eggs. Let me find my mouse, which is here. So this will pertain to this. This is, it doesn't break, so I still have 2 eggs, but now I only have 1 level remaining, because now my building has only 3 levels. Okay, let's go on to this last line. At level 3, an easy solution, if it doesn't break, then we will have our solution already. So if it breaks, then we only have 1 egg remaining and 2 levels. So the number will be 2, which I'm going to put over here. In this column, we take the maximum of the 2 and we add it to the current drop. So I have 3, 2, and 3. I take the minimum value, and this 2 will be placed in here, where I have 3 stories and 2 eggs. Okay. Okay, let's look at this final example when we are considering a 4-story building. Once again, we have 2 eggs and we need to iterate through the 4 levels. So at this first level, we drop the egg 1. There are only 2 options, whether it breaks or it doesn't break. If it breaks, we have found the solution, so we don't need to drop anymore. Now if it doesn't break, we have 3 more levels to test. And because it doesn't break, we have 2 eggs remaining, and so this number will then be 2, which I put it over here. Let's go down to level 2. Again, it will either break or it doesn't break. If it breaks, we will have 1 level and only 1 egg remaining, so this will be 1. So what happens if it doesn't break? If it doesn't break, we will have 2 eggs remaining and 2 levels. 2 eggs remaining at 2 levels will be 2, and we're going to put this number over here. At level 3, the current drop is 1. At the current drop, if it breaks, we will have 1 egg remaining, and we have 2 more levels to test. And so I have a number 2 here, which pertains to this. Now if it doesn't break, and this is a 4-story building, I have 1 level remaining, but I have 2 eggs on hand, so this is number 1. I put it over here. At level 4, if it breaks, I have 1 egg remaining and 3 levels, so it's 3 over here. If it doesn't break, I'm done. So I take the maximum of this 2, which is 2, plus the current drop 3, maximum which is 2, current drop 3, maximum 2, current drop 3, maximum 3, current drop 1, 4. And take the minimum of this, which is 3, and I put it over here. This should be the optimal solution if I have 4 levels and 2 eggs. And similarly, you can use this algorithm to run through as your levels come to an end. Then you increase your egg again, and then run through the levels again. And this is the optimal solution which was presented in the tutorial. Thank you.